K-tutorial number 2, Defining IMP, Lesson 2. Here we learn how to define a configuration in K. We also learn how to initialize and how to display it. As explained in the overview presentation on K, configurations are quite important because all semantic rules match and apply on them. Moreover, they are the backbone of configuration abstraction, which allows you to only mention the relevant cells in each semantic rule, the rest of the configuration context being inferred automatically. The importance of configuration abstraction will become clear when we define more complex languages, even in IMP++. IMP does not really need it. K configurations are constructed making use of cells, which are labeled and can be arbitrarily nested. Configurations are defined with the keyword configuration. Cells are defined using an XML-ish notation stating clearly where the cell starts and where it ends. While not enforced by the tool, we typically like to put the entire configuration in a top-level cell called capital T. Cells can have other cells inside. In our case of IMP, we need a cell to hold the remaining program, which we typically call K, and a cell to hold the program state. Let us add them. K allows us to also specify how to initialize a configuration at the same time with declaring the configuration. All we have to do is to fill in the contents of the cell with some terms. The syntactic categories of those terms will also indirectly define the types of the corresponding cells. For example, we want the K cell to initially hold the program that is passed to krun. K provides a built-in configuration variable called $pgm with capital letters, which is specifically designed for this purpose. krun will place its program there, after it parses it, of course. The K tool allows users to define their own configuration variables too, which can be used to develop custom initializations of program configurations with the help of krun. This can be quite useful when defining complex languages, but we do not discuss it in this tutorial. Moreover, we want the program to be a proper program term, because we do not want to allow krun to take fragments of programs, for example statements. Therefore, we tag $pgm with the desired syntactic category, pgm. Like for other variable tags in K, a runtime check will be performed and the semantics will get stuck if the passed term is not a well-formed program. We next tell K that the state cell should be initialized with the empty map. Recall that in K, dot stands for nothing. However, since there are various types of nothing, to avoid confusion, we can suffix the dot with its desired type. K has several built-in data types, including lists, sets, bags, and maps. .map is the empty map. Compile imp.k and run several programs to see how the configuration is initialized as desired. Also, compile with the option --pdf to see how configurations are displayed in the documentation, like nested labeled bubbles, where each bubble is a cell. When configurations get large, and they do when defining large programming languages, you may want to color the cells in order to more easily distinguish them. This can be easily achieved using the color cell attribute, following again an XML-ish style. Compile again with the PDF option and take a look at the new configuration. The cells should be now colored as indicated. In the next lesson, we will learn how to write rules that involve cells.